Use the 7th edition here. I think I took the 8th edition home. I like to do it for like some bedtime reading, you know. So just decided to use the 7th edition here. What's up?
I like math, but I don't know if I like it that.
It's kind of like bedtime stories for my kids. Calculus. Okay, here we go. 7.5. I have the 7th edition here, so if you have the 7th edition, that's great. Let's look at this integral. It's going to have a bunch of integrals, going to try to figure out how to do them. Integral from 0 to 1, 3x plus 1 to the square root of 2 dx. Solution. I'm going to do u equals 3x plus 1, du equals 3 dx. If x equals 0, u equals 1. If x equals 1, u equals 4. So that's going to be the integral from 1 to 4, u to the square root of 2 du over 3, which is 1/3 u to the square root of 2 plus 1 over square root of 2 plus 1 from 1 to 4, which is 1/3 times 1 over 1 plus square root of 2 times 4 to the square root of 2 plus 1 power minus 1 to this whatever power is 1. So that's a weird answer, but I think it's right. I'm not going to check because it's an even number. So pretty sure that's right though. That was number 2. Let's do number 4. Integral sine cubed over cosine dx. Let's see. Solution. I think I'm actually going to go, let's see. I think I'm going to pull off a sine. So I'm going to try to use the strategy where I pull off a sine of x and set up a u sub for cosine. So I get sine squared over cosine. And the sine x dx is going to be over here off to the side, waiting to be a u sub for cosine, basically. So I'm going to try to set up the u sub for cosine. And I can change sine squared to 1 minus cosine squared over cosine sine x dx. And now I can do my u sub, u equals cosine. du is negative sine x dx. So this is going to be the integral 1 minus u squared over u times du, negative du. So this is going to be integral 1 over u minus u negative du, which is going to be negative natural log absolute value of u minus u squared over 2 plus c, which is going to be negative and then natural log absolute value cosine x minus cosine squared, plus cosine squared x over 2 plus c. Of course, I could change that to natural log secant. If I want to pull that negative in as the exponent of the cosine, I could say that that's 1 over cosine. That makes sense? So I could say natural log secant plus cosine squared over 2 plus c. Example. I've never seen those first two in my life. Next one, integral, this is number 6, integral from 0 to 1, x over 1, or x over 2x plus 1 to the third dx. Let's see, I'm probably going to do a u sub again here. I'm going to do u equals 2x plus 1 du equals 2 dx. However, I have an x in the numerator, so let me solve for x here. So x is equal to u minus 1 over 2. And let's change the bounds. If x is equal to 0, u is equal to 1. And if x equals 1, u equals 3. So we'll get the integral from 1 to 3, 1 over u cubed. X is u minus 1 over 2. And then du over 2. So that's a u sub where I have to kind of solve for the x in the u sub in terms of u so that I can plug it back into my integral. So that's a little sneaky or a little tricky. But does it make sense what I did there? I kind of used the u sub for everything it was worth. I changed my 2x plus 1 to u. I changed my dx to du over 2. I also changed x to u minus 1 over 2, and I changed the bounds. So I basically did everything I could possibly do with this u sub. Okay. And now it's nice and algebraic, so I'll just pull out that 1/4 to the front. Integral from 1 to 3, u minus 1 over u cubed du. So that becomes 1/4 integral from 1 to 3. Let's see, 1 over u squared minus 1 over u cubed du. It's going to be 1 over 4 times, let's see, 1 over u squared integrates to negative 1 over u minus negative 1 over 2u squared from 1 to 3. Did I do that right? That's u to the negative 2 and u to the negative 3. And my power law is that the integral of u to the m du would be u to the m plus 1 over m plus 1. But basically, if I plug in m equals negative 2, I get u to the negative 1 over negative 1. So that's 1 over u, or negative 1 over u. And then 1 over u cubed goes to negative 1 over 2u squared. So basically, this is m equals negative 2. And this is m equals negative 3. And all we have to do now is plug in the bounds. So 1 over 4, negative 1 over 3, plus 1 over 2 times 9 is 18, plus 1 over 1, minus 1 over 2. So that's 1 over 4 times, let's see, negative 1/3 is negative 6 over 18 plus, so that's negative 5 over 18 plus 1 minus 1/2. So that's going to be 1/4 times, let's see, this is 1/2, so minus 4 over 18. So this is going to be 1 over 18. Just make sure I did my arithmetic correctly there. This is a 1/2. It's negative 5 over 18. That's going to be 9 over 18, which is 4. 9 over 18 minus 5 over 18 is 4 over 18. Right there. Times 1/4. 4's cancel. Get 1 over 18. Next one. Number 8. So this is basically Stewart Chapter 7, Section 5, 7th edition, number 6. Now we're doing number 8. This is integral t sine t cosine t. dt. So this one is a little tricky because of the t in the front. So if the t was not there, I would just either use a trig identity or I would do a u sub, u equals sine. But since that t is in the front, that's a little tricky. So I have algebraic times trigonometric. So what I could do is use like a trig identity, then integration by parts, right? Sine t cosine t, sine t cosine t is equal to 1/2 sine of 2t. And so I think that's probably the best way to go on this one. So then integrate by parts. So our integral becomes t times 1/2 sine of 2t dt. Let's get 1/2 integral t sine 2t dt. And let's see, I'm going to pick u and a dv. So u equals t, dv equals sine of 2t. du is dt. V is -1/2 cosine 2t. This is going to equal 1/2 integral, 1/2 times uv, which is -t/2 cosine 2t, minus integral -1/2 cosine 2t dt. uv minus integral v du. Let's see, this is going to equal -t/4. Well, let me not do that yet. I'll keep the 1/2 out front. And -t/2 cosine 2t. And the negatives here are going to cancel, so I'm going to put this as a positive 1/2. So plus 1/2 times, and integral of cosine 2t is going to be 1/2 sine 2t. And then plus c. Now I can distribute everything and simplify. So this is going to be -t/4 cosine of 2t plus 1/8 sine of 2t plus c. So that's a little tricky because you had to use that trig identity before you integrated by parts. That make sense? Cool. Number 10. It says integrate x minus 1 over x squared minus 4x minus 5 dx. Integral from 0 to 1. Integral 0 to 4. All right, so I try to classify it, right? Like, it's irrational, so I immediately think partial fraction decomposition. Right? Maybe a u sub would work. Would a u sub work? No, because the derivative of the bottom would be 2x minus 4. And the top is not a multiple of 2x minus 4. It's just x minus 1. It would have to be x minus 2 in the top if it was going to be a multiple of 2x minus 4. So it's not going to work for u sub, at least not an easy u sub. So I'm going to try to factor this denominator, see what it factors as. X minus 5 plus 1. Those are my factors. So then I'm going to do the partial fraction decomposition here. X minus 1 over x plus 1 times x minus 5 equals a over x plus 1 plus b over x minus 5. And I clear the denominator, so you get x minus 1 equals a times x minus 5 plus b times x plus 1. And it's linear factors, so strategic values work. So I'll pick x equals 5. So over here I get 4. Over here we get a times 0 plus b times 6. So b is going to be 2 over 3. And then if I pick x equals -1, I would get -2 over here, a times -2 minus 5. Sorry, -1 minus 5. A equals, let's see, -2 over -6 is going to be 1/3. So basically I can erase a and b here and say that this is going to be 1/3 and 2/3. So I did my partial fraction decomposition, and now I can integrate from 0 to 4. So integral 0 to 4, 1/3 times 1 over x plus 1 plus 2/3 times 1 over x minus 5 dx. It's going to be 1/3 natural log absolute value x plus 1 plus 2/3 natural log absolute value x minus 5 from 0 to 4. That's going to be 1/3 natural log absolute value 5 plus 2/3 natural log absolute value 1 or -1 minus 1/3 natural log absolute value 1 minus 2/3 natural log absolute value -5. Let's see. Some of these are going to go away. Natural log of 1, that's 0. Natural log of -1 absolute value, that's 0. So we get 1/3 natural log of 5 minus 2/3 natural log of 5. It's going to be -1/3 natural log of 5. And you could rewrite that as maybe like 1/3 natural log 1/5. You pull that negative into the log as the exponent on the 5. It would be 5 to the -1, which is 1 over 5. But that's the answer? Well, assuming I didn't make any mistakes. I always assume I don't make any mistakes. Just kidding, that's a horrible way to operate. Everybody makes mistakes. Let's look at number 12 here. Any questions so far? Number 12. Questions so far? 12 is integral x over x to the 4 plus x squared plus 1 dx. Looks a little tricky. It's a rational, but it's got a fourth power in the bottom and an x on top. I'm tempted to do a u sub to get the x out of the top. Does that make sense? If I do a u equals x squared, then that bottom would become u squared plus u plus 1. And the top would kind of go away. So then I basically just have to integrate 1 over u squared plus u plus 1. So let's look at that. So I'm going to try a u sub. U equals x squared du is 2x dx. But I don't have the 2, so I say du over 2 equals x dx. So my integral will become integral, let's think about this. U equals x squared. So u squared equals x to the 4. So it becomes 1 over u to the 4. U squared, sorry. 1 over u squared plus u plus 1 du. And now I don't know what to do. Maybe I can complete the square on the bottom. Just going to try that just to see what happens. I'm going to complete the square on the bottom. So because I don't really know what to do, I want to try to complete the square on the bottom. So I literally don't know what to do, so I'm starting to be creative. Okay, this is where I'm just trying something. Okay, so let's see, that'll be u squared plus u, ooh, gross, 1/2. So plus 1/4 plus 1 minus 1/4. So basically I'm adding and subtracting 1/4. So that'll be u plus 1/2 quantity squared minus, no, plus 3/4. This one I'm a little nervous about. So this will be 1 over u plus 1/2 squared plus 3/4 du. And so here I'm going to do another substitution. W equals u plus 1/2. dw equals du. So this becomes integral 1 over w squared plus 3/4 dw. Okay, does that make sense so far? So I just kind of got a little creative because I kind of ran out of things to do. My partial fractions weren't going to really work out because I couldn't factor it perfectly. Right? I would get complex factors, I think. So now it's an arctangent. We just have to remember our arctangent formula. Integral 1 over x squared plus b squared dx was 1 over b arctan x over b. So here b squared is 3 over 4, so take the square root of that. So this is going to be 1 over square root of 3/4 arctangent w over square root of 3/4 plus c. But we have to go all the way back to x. So this would be square root of 4/3 arctangent. Let's see. Write it this way, square root of 4/3. W is u plus 1/2. But what is u? U is x squared, so I put an x squared right there. So let me just rewrite it one more time. This is going to be 2 over square root of 3 arctangent 2 over square root of 3 x squared plus 1/2 plus c. And we'll call that our answer. I'm a little nervous about that one, to be honest. Pretty sure that's right. So this one I think I want to check. I feel pretty confident about it. So just gonna check it really fast. I think Wolfram can do these. Look at that. Where's the 2? Oh, there was a 1/2. Shoot. I forgot my 1/2 on my du. If you recall, this should be over 2, over 2, over 2. So that should be a 1/2 here, 1/2, and then 2 would cancel. So that makes it a 1. Yeah, forgot my du over 2. Cool, cool. Tricky. That's tricky. Feels good though. I mean, except I forgot the 1/2. That doesn't feel good. I might as well have gotten it wrong personally. But it did feel good to kind of like just try something and be creative and figure it out, you know. That's the name of the game right there. You start figuring it out on your own, that's how you know you're getting it. Okay. If you can start to do that, you should feel confident on the exam or heading into the exam. That's the name of the game. Let's see, number 14 here. Ooh, looks tricky. Integral x cubed over square root of 1 plus x squared dx. I think I'm going to do a u sub. I could do a trig sub. What do you want to do? Trig sub or u sub? You shot me down so quickly. Shot me down. Okay. You don't want to do trig sub?
No.
Anybody want to overrule Armand? It's a democracy. I need some people in the chat to vote. Trig sub or u sub?
Yes, yes.
I'm down for trig sub.
That was earlier. Can you hear me? Check, yeah. Thank you. Thank you. Very good. Very good. Everybody said trig sub.
Right now in the chat. You're like, why?
Okay, so we're going to trig sub. We're going to let x equal tan theta, right? Dx is going to equal secant squared theta. D theta. The people have spoken, that's right. Snap, pulling in the red versus blue. Oh, snap. All right, here we go, here we go. X equals tan theta because I have 1 plus x squared under the radical, right? So 1 times tan theta is my substitution. Dx is secant squared theta d theta. So this is going to become tan cubed theta over square root of 1 plus tan squared theta secant squared theta d theta. It's going to be integral tan cubed over square root of secant squared and then secant squared theta d theta. And that square root of secant squared is just secant, so that's tan cubed over secant squared d theta. So secant cancels with the square. So we have integral of tan cubed theta secant theta d theta. And I think we're going to convert this over to a u sub for secant. Okay, because I have 1 secant and I can pull 1 tangent off and make it a u sub for secant. So this is going to be integral secant or tangent squared theta and then secant theta tangent theta d theta. So we're basically setting ourselves up for a u sub for secant. So now I have to convert tangent squared to secant squared theta. Minus 1 secant theta tangent theta d theta. So u equals secant theta. Du is going to be secant theta tangent theta d theta. So this is going to become integral u squared minus 1 du u cubed over 3 u cubed over 3 minus u plus c. And so that's secant cubed theta over 3 minus secant theta plus c. And go back and draw our triangle. So here's theta. Tangent theta is x over 1. The hypotenuse is 1 plus x squared under the radical. So secant theta is hypotenuse over adjacent, which is square root of 1 plus x squared. So this is going to be 1/3 1 plus x squared to the 3/2 minus square root of 1 plus x squared plus c. So u sub, you get the same thing. You just have to be a little sneaky about it because you just pull one of the x's off to go with the dx for the u sub, and then you do u equals 1 plus x squared. Solve for x squared to get u minus 1 for x squared for the numerator, basically. Because you're only pulling one of the x's off to go with the dx, you still have the x squared up there. So you could do a u sub, but the trig sub was way more fun. Armand is shaking his head. He totally agrees now. He says, I was so wrong, but I'm so glad we did a trig sub instead of u sub. That's exactly what he's doing right now. He's shaking his head profusely, which is true. He is shaking his head profusely. All right, next. Next one has to be trig sub. So, sorry. We voted for trig sub, and now we have to do trig sub. Integral from 0, I can edit it out, it's okay. Square root of 2 over 2. X squared. Square root of 1 minus x squared dx. So this one we have to do trig sub. X equals what? It's all based on the form of the radical. Under the radical, I have 1 minus a variable squared. So I'm going to let x equal sine theta. That's right. X equals 1 times sine theta because the coefficient, or the number squared is 1 squared. So 1 sine theta dx equals cosine theta d theta. So if x equals 0, then that tells me sine theta equals 0, so theta equals 0. And if x equals square root of 2 over 2, that's equal to sine theta. And then theta would equal, what angle do I take the sine of to get square root of 2 over 2 in my restricted piece? Yeah, pi over 4. That's right, pi over 4. Very good, very good. Solution. So this is going to become the integral from 0 to pi over 4. And then we have sine squared theta over the square root of 1 minus sine squared theta cosine theta d theta. Oh, snap. It's going to be the integral from 0 to pi over 4 sine squared theta over, that's square root of cosine squared, right? Square root of cosine squared times cosine d theta. And that square root of cosine squared is going to cancel with the cosine. So it's integral of sine squared from 0 to pi over 4. So integral of sine squared, anybody? How do we do that? How do we integrate sine squared?
Is there an identity that you can use?
Use the power reduction identity. So this is going to be the integral from 0 to pi over 4. Sine squared is 1/2 1 plus minus 1 minus cosine 2 theta d theta, which is going to be 1/2. Integral of 1 is theta, negative 1/2 sine of 2 theta from 0 to pi over 4. Plug in those bounds. This is going to be 1/2 times pi over 4 minus 1/2 sine of 2 times pi over 4 minus 0 plus 1/2 sine of 0. And those two are kind of irrelevant. This is 0. Obviously, this is 0. Sine of pi over 2 is 1, so this is going to become 1. So pi over 4 minus 1/2, basically, inside the parentheses. So this is going to be 1/2, and then pi over 4 minus 1/2 equals pi over 8 minus 1/4. Cool. So cool. So cool. All right, questions so far? So cool. Questions online? It's all good. So far, so good. Number 18. This one says integrate from 1 to 4 e to the square root of t over square root of t dt. Let's see. Derivative of square root of t is 1 over square root of t, so I kind of have the derivative of square root of t there already. So I'm going to do a u sub u equals square root of t du equals 1 over 2 square roots of t dt. So I have the 1 over square root of t, so I need to say du over 2 equals 1 over square root of t dt. That's du over 2. So if t equals 1, u is equal to 1. And if t equals 4, u is equal to 2. If I run it through the square root function, that's how I get my bounds for u. So integral from 1 to 2, e to the u du over 2. So it's going to be 1/2 e to the u from 1 to 2, which is 1/2 e squared minus e. Seems too easy compared to the last two. I'm not going to complain. If he wants to throw some easy ones on the exam, just roll with it. Just take the free points. Cool. Next one, number 20. There's something in the chat. Scroll up. Yes, sorry. Is that good? Number 20 says find the integral of e squared dx. Integral of e squared dx. What do you think? What's the integral? E squared dx.
E squared x.
Plus c, that's right. Oh, okay. Phew. I thought I screwed up the previous problem because I forgot plus c, but it was a definite integral. So we're good. I almost had a heart attack. Can't forget plus c. This is going to be e squared x plus c. They're trying to trick you. They're trying to make you think, oh, it's just e squared plus c, but there's no variable there in the e, so trying to trick you. It's a little trick question. Trick question. It's just a constant. So antiderivative is just constant times x plus c. Constant here is e squared. All right, number 22. see, this one is a little interesting. It says natural log x over x times square root of 1 plus natural log x quantity squared dx. I'd call this one, I'd use Dr. Gord's phrasing. He used to use this phrase a lot back in the spring in the cryptography class that I was in. And I'm going to call this thing an onion. Okay, you just have to peel back the layers of the onion. Okay, so the first thing, the derivative of natural log is 1 over x. So I kind of see that here already, 1 over x right there. So I'm going to go ahead and do a u sub for natural log just to kind of start peeling the onion back. So u equals natural log x, du equals 1 over x dx. So then my integral becomes integral u over square root of 1 plus u squared du, which is much more manageable, right? And now Armand says, let's do trig sub, right? U equals tan theta. Armand's changing his mind. Armand no longer wants to do trig sub. All right, so what do you want to do instead? Just, I kind of want to chill. Kind of want to sit back, get some popcorn. It's not Friday yet. That's right. All right, so I'm going to do a w sub. W equals 1 plus u squared. dw equals 2u du. So then my integral becomes integral 1 over square root of w dw over 2. So this is going to be 1/2 integral w to the negative 1/2 dw. So that's going to be 1/2 w to the 1/2 multiplied by the reciprocal, which is 2, plus c. 2 and the 1/2 cancel. It's just square root of 1 plus u squared plus c, which is square root of 1 plus natural log x squared plus c. So it's just an onion. You have to peel back the layers. It's pretty cool, huh? This just gets your engine revved up doing these integrals. It's freaking awesome. It's so exciting. This is amazing. We're just doing cool stuff today. This is what I want to do every day. I just want to work all of the all of the problems in the book, in the section. That's all I want to do every day. I really want you guys just to read the book, and then we come in and then work all these even number problems. I mean, yeah, exactly. I mean, okay, number 24. Oh, we got a chat. E to the 2a. Scroll sounds like the best day ever. You're not wrong. It is. It's a good day. It's a good day. All right, integral 0 to 4. So 6z plus 5 over 2z plus 1 dz. So I got a couple of approaches I could take with this one. I could do the little trick, but it's a little tricky. Or I could do just the regular rational function strategy. So I have a rational function. What's our strategy? Well, if the degree of the numerator is the same or larger than the degree of the denominator, I need to do a long division. So I'm just going to go ahead and do the long division because that's like a guaranteed strategy. So let's do that. So I'm going to do 6z plus 5, and the long division is dividing this by 2z plus 1. So what do I need to multiply 2z plus 1 by to get 6z? 3. So 3 goes right here. I get 6z plus 3. Subtract that. I get 2 as my remainder. So basically, I'm going to integrate 3 plus 2 over 2z plus 1 dz, which is going to be 3z plus integral 2 over 2z plus 1 dz. Oh, from 0 to 4, right? I have bounds. Don't forget the bounds. From 0 to 4. All right, so what's up with the second integral? How am I going to do that? The integral from 0 to 4, 2 over 2z plus 1. U sub, yeah, u equals 2z plus 1. du is going to be 2 dz. Aha, very good. I have like du right there already. And I guess I'll change the bounds. So if u is equal to 0, or sorry, if z is equal to 0, u equals 1, and if z equals 4, u equals 9. Is that right? Did I do that right? I feel like I did. Plug in z equals 0, I get 1. Plug in z equals 4, I get 9. Okay. So this is going to equal 3 times 4, which is 12, plus integral from 1 to 9, 1 over u du, which is 12 plus natural log absolute value u from 1 to 9, which is going to be 12 plus natural log of 9. Natural log of 1 is 0, so I don't have to subtract the natural log of 1. Okay, does that make sense? Man, that was awesome. The more we do, the more excited I get. Just saying. Just saying. Any questions so far? We've done 12 integrals today. 12 examples. We have done 12 examples today so far. We're just ripping it up, you know? Shredding. Spitting fire. Spitting the fire. Playing the game, and we're winning. Just saying. I've already got 120 points racked up for this exam. Well, I got a -2 on the one, I forgot the 1/2 du. So I got a 118. I got a 118. What's up?
Something's better than nothing.
Something's better than nothing, that's correct. I'm just hoping for partial credit on this exam, to be honest. I mean, number 26. Integral 3x squared minus 2 over x cubed minus 2x minus 8. I think I've met my match. I'm going to have to factor this, or wait a minute. Hey, u sub for the denominator. Oh, hello. Look at that. U sub for the denominator. The derivative's in the top. It's not hard. I think I felt intimidated because it was x cubed, but then I was like, hold up, fam. I got this. So I say u equals x cubed minus 2x minus 8. That looks like a Chinese communist symbol. Sorry. Stop making the political references. Du equals 3x squared minus 2 dx. So du goes right here. Gonna get this integral 1 over u du. Oh snap, this is so easy. Plus c. This is a natural log of x cubed minus 2x minus 8. It's just like a rush of dopamine every time I get one of these. It's just like, man, I just get you revved up, man. It's freaking sweet. Killing it. So killing it. Just killing it. So exciting. This is normally like what I'm like every day. Whenever we have like a full class and I can walk around, I'm not confined to this, prison of plexiglass. Yeah, it's way more fun normally. Like I'm trying to. Yeah, well, I thought about it, but then I was like, well, you're still not supposed to get like within 6 feet of people. It's like if you have to, like if you're in a lab or something, then they're like, oh, it's okay. But then they're like, no. Yeah. Okay. Number 28. Here we go. Pretty sure we did one like this already. Integral sine square root of at dt. squared AT. So I think what we should do here, I think we did this one actually in our integration by parts section. When we went over integration by parts, we did something very similar to this. I think it's just square root of t, not square root of AT. So basically what we do is we do u equals, I think we do u equals square root of AT. And then from there, I think what we should do is go ahead and solve for t and then take the derivative of t with respect to u. So that would be u squared over a equals t. So I can actually get that dt would be 2u over a du. That makes sense? I kind of like flipped the u sub around. Like I kind of got tricky with it and I said, okay, let me go ahead and solve for t and then take the derivative to get dt. So did you see how that happened? It's pretty cool. It's pretty sick. So integral, oh, wrong color. Integral sine of u 2u over a du. So I'm gonna pull the 2 over a out. And it becomes integral of u sine u du. Ooh, tricky. Now it's integration by parts. They knew I was going to use u, and they knew it was going to be integration by parts, so they did it this way so that I would use u, and now I'm like, well, integration by parts is uv minus integral v du, so I already got u in there. Got me. So I should have used like w, right, or some other variable like x. I don't know why I didn't use x. Oh well. So let's say x equals u, dv equals sine of u du, and dx equals du, v equals negative cosine of u. So I'm going to do xv minus integral v dx. So normally that's not the formula we use necessarily, but it's going to be negative u cosine of u minus the integral negative cosine of u du. So that's 2 over a times negative u cosine of u plus integral of cosine is sine plus c. And then plug in what u is square root of at. So this is going to be 2 over a times negative square root of at cosine of square root of at plus sine of square root of at plus c. Again, I feel pretty confident about that one. I don't feel the need to check. Feeling pretty good. Example number 30 from Stewart, 7th edition, section 7.5. This looks a little tricky. Integral from negative 1 to 2, absolute value e to the x minus 1 dx. So that's tricky. So I don't know if I told you guys, I think I told you guys this, but I was like, I had a grad student who would come by my office a lot when he was teaching calculus, and he was like, you want to make anything infinitely harder? Just stick an absolute value on it. And I was like, you're so right. Like that just intimidates the heck out of people, you know? So what do we do with this? Yeah, exactly. We're going to graph this first. All right. So try again. Sorry. E to the x here in the whitish gray color. E to the x minus 1. Green color. Hey, we can hear you. All right. It was very humorous, though. Thank you for Sound effects, yes, exactly. All right, so e to the x minus 1 is going to be something like this. And then absolute value is basically going to flip that over here and then go up like this. So this absolute value e to the x minus 1, whereas the green one was just e to the x minus 1. So basically from -1 to 0, I'm going to do the negative of e to the x minus 1 plus the integral from 0 to 2. I'm just going to do the function e to the x minus 1 dx. So basically absolute value of e to the x minus 1 is this piecewise function, negative e to the x minus 1. X is less than 0. And e to the x minus 1 if x is greater than 0. So that's all there is to it. It's not really a big deal, right? Just throw an absolute value on something. No big deal. You got this, right? All right, now just integrate. Get negative e to the x plus x from -1 to 0 plus e to the x minus x from 0 to 2. Plug in those bounds, get negative e to the 0 plus 0 plus e to the -1 minus 1. So that's all from the first term plus the second term, e squared plus minus 2 minus e to the 0 plus 0. And this turns out to be, let's see, that's a -1 plus e to the -1 minus 1 plus e squared minus 2 minus 1. And that reduces to e squared plus e to the -1 minus 3 minus 4 minus 5 minus 5. I think that's our answer. So sick. So good. Man, it's exciting. That's so good. Number 30. Good one. Ooh, 32 looks really tough. Let's try it. Integral says in the numerator, square root of 2x minus 1. The denominator is just 2x plus 3. That looks really tough. I don't know what to do. I guess maybe a u sub, but that looks like it might not work so well. I guess just do u equals 2x, so then it'd be u minus 1 over u minus, or u plus 3. Tricky, tricky, tricky. Sticky. Got any ideas? Scroll down. Same, make it smaller. Is that what you meant? No, you said scroll down. Sorry, I went the wrong way. Okay. Okay, I may really have met my match here because we only have 8 minutes left and I'm not really sure what to do on this one. I may multiply top and bottom by the radical conjugate, but probably not. It's not really a rational function because the radical in the numerator. Let's see if I can't do something. If I do u equals 2x, I'll get square root of u minus 1 over u plus 3. I'd like to get rid of the radical. So why don't I try u squared equals 2x minus 1? Seems a little sneaky, but what the heck, why not? So then 2u du equals 2 dx. So u du equals dx. So now I'm doing something that's like really fishy. I took the derivative on the left with respect to u. I took the derivative on the right with respect to x. It's like implicit differentiation almost. And I'm going to solve for 2x. So 2x is equal to u squared plus 1. So then 2x plus 3 would be u squared plus 4. So I'm going to turn this into the integral square root of u squared over u squared plus 4 du du. So this is going to be the integral of u squared over u squared plus 4 du. Aha! That worked. Look at that. Just made up something. I got creative again. So I'm going to add and subtract 4 since we don't have a lot of time. So make that u squared plus 4 over u squared plus 4 minus 4 over u squared plus 4 du. So that's going to be integral of 1 minus 4, 1 over u squared plus 4 du is going to be u minus 4 over 2 arctan u over 2 plus c. And u is square root of 2x minus 1. So this is going to be square root of 2x minus 1 minus 2 arctan square root of 2x minus 1 all over 2 plus c. And that one I'm going to check just because I'm pretty sure it's right. That feels good, but I'll probably check that one just to make sure it's right. I'm feeling good about it though. So I got really sneaky on that one. I did like a u sub kind of. I did an implicit substitution is what that's called. I let u squared be equal to 2x minus 1. Not just u, but I let u squared equal 2x minus 1 because I wanted the radical to go away. So I picked u squared. And so on the left, I differentiated with respect to u. On the right, I differentiated with respect to x to get my differentials connected to each other. And then I just solve for dx. So I can substitute u du into the integral for dx. I also had to solve for 2x plus 3, and that turned out to be u squared plus 4. So that was a little tricky. That one's probably the trickiest I've ever, well, I wouldn't say I've ever done in the class, but it's one of the trickier ones I've ever done in a Calc 2 class. So.